Good afternoon, everyone. President Awwad, members of the President's Cabinet, esteemed faculty members and colleagues, good afternoon. On behalf of the American University of Kuwait, I would like to welcome you all to the last lecture of the faculty speaker series for this academic year. Today, our speaker, Dr. Rababah, will be presenting a new simple programming language for education. Before we start, I would like to thank, first of all, President Awwad for her leadership and continuous support. I would also like to thank Dr. Salim Ismadi, the co-chair of the Faculty Speaker Series. I would also like to thank the IT department and the PR departments for providing the support to make this event happen. And for now, I would like to start by reading Dr. Aaron's bio. Dr. Aaron Rababah joined the College of Engineering and Applied Sciences at the American University of Kuwait in January 2016 as an associate professor. Previously, he held the following academic positions in the United States: associate professor and assistant professor at the University of Maryland, Eastern Shore, postdoc researcher and instructor at Tennessee State University, and adjunct instructor at Indiana University of South Bend. He finished a Bachelor of Science in Industrial Engineering from University of Jordan, a Master's of Science in Applied Computer Science from University of Indiana, and a PhD in Computer Information and Systems Engineering from Tennessee State University in the United States. He has 5 years of experience in industrial engineering and 11 years of experience in teaching at the college level. He has research interest in machine intelligence and computing education. He has published 4 books, 90 refereed journal and conference papers, and has 50 professional presentations. He received several awards in education, research, and industry. And he has supervised and referred senior projects, master theses, doctoral dissertations, and a number of journals. He has been funded by the USA Department of Defense, the US Army, NASA, National Science Foundation, and MD Department of Education. Dr. Aaron, I would like to invite you to start with your presentation.
Assalamu alaikum, everyone. Good afternoon. Thank you so much, Fatima. Thank you, Dr. Salimi. Appreciate your efforts of making this event hopefully a successful event, and I appreciate this opportunity to share with my colleagues this AUK community and also the public and our engineering and academic society at large. Should I start sharing my screen now?
Yes, please.
All right. Is it visible now?
Yes.
All right. Thank you so much. Thank you, everybody, for coming to the presentation. I really appreciate your support. Without any delay, I would like to jump right in to the topic. This is the front page of the presentation. As you can see, the title is about a new programming language, which I have developed, and it took me a few years to accomplish. And I would like to make a note here and apologize. Actually, it's going to be a little technical and underline little there. I'm sorry for that, but that's the nature of the topic. And I hope that you're not bored of attending this presentation. I hope so. I will do my best to entertain as much as I can. So this is the outline of the presentation. And we go to the introduction right away. Just a brief introduction about the subject of SIMPLE. SIMPLE is an acronym that I came up with that stands for Simple Imperative Model Programming Language for Education. The really motivation behind this project is the lack of literature. This is not an easy topic. We all, as my colleagues in engineering and computer science, we teach programming, and that's one thing of teaching and knowing how to program. But taking the challenge of creating a programming language, I understand that is not a duty of an instructor to do that, but it's an amazing journey, an amazing challenge that it would be an amazing opportunity for us and a learning journey for any educator that I actually decided to do. That's the challenge I decided to take on in this project. And also, I saw a great benefits to our students if I integrated this tool as a tool in different, CS classes. I saw a great educational benefits that we'll talk more about. The SIMPLE is a procedural compiled high-level language. So it's not actually low level. We can think about the abstraction levels and computer systems. That goes all the way from the hardware, logic design, and then you go to the microarchitecture, you go to the CPU language, which is the binary or machine language. You go up another level for assembly, and you go multiple levels all the way to, to the user level. But our language is a high level. That means it looks like Java, it looks like Python, it looks like, let's say, MATLAB, at that level of accessibility to the user or to the programmer, better said. So if you want to take this challenge, start looking around and researching and seeing what are the involved tools in this domain. And I am, let's say, a Java programming language instructor. So it is naturally for me to use Java. So there's other tools that people are using, like Lex and Yak and Flex and Bison for C, C++, and these kind of languages. But for Java community, we have a Java CC front end that people are interested to do to explore compilers. It is the best tool out there. So this is our front end, if I can use a pen here, right? And for the back end, it's an x86 machine code, which is understandable that every language, may target, especially the compiled, right? Compiled languages, you need to target a specific CPU, and our target is the x86, which is the Intel machines. And probably it's 80% of the market, and you can't go wrong with that. And besides, many departments all over the world is using this as a tool, x86 machine code, and we teach it at AUK as well in our department. That is the assembly language we teach in our department. So some people may ask, why SIMPLE? Why we started this project? Since a programming language, there's actually hundreds of programming languages in the world. But it's not reinventing the wheel, but it is a really educational and learning journey that I basically decided to go through in order to provide myself with this learning experience and provide my students with the access to not only how to program, but actually how do you, if you wanted, how do you invent your own programming language? Excuse me. I can see many ways that I can utilize this programming language as a programming in 101 advanced level of programming, and in assembly language. We can utilize that in concepts of programming languages and compilers, and we have all that at AUK. So I think it's a great tool to be an open source, to have all these developed components accessible at all kind of levels, all levels of abstraction and computer system to our students. And another objective I had in mind, because when you are given a language, most likely you like some of its features and you don't like some others. So that's what my feeling about different languages, and I wanted to contribute to hopefully simplifying some of the complicated things that beginners are facing in order to hopefully ease the first steps toward learning about coding and programming, especially our 101 students. 101 as a general name, but we have a 120 class, but 101 is the general term for beginners. So when we looked around and then who's doing this kind of work, really we couldn't find a handful of educators that are doing the same thing as I am doing. And these are some examples. We're not going to go through the literature or these references, but these are a few examples. And if you look around and search, you won't find too many projects of this kind. I think because it's just too challenging and it's just time consuming. And for me, it took really few years to accomplish, which I don't regret any minute of it. It was an amazing, an exciting learning experience. So if you talk about theoretical background, when you get into this domain, you need to have understanding of what is really a language and how do we actually create a language, and what type of implementation methods that are established in this domain, and which one would you pick? Interpretation is one of them that it wasn't appealing to me because the stack of this development framework is shallow. And if you know about interpretation, it just targets the virtual machines and the computer systems, and your stack is just shallow, not deep enough in order to accomplish the learning objectives and accessibility to all levels of abstraction. Compilation, on the other hand, it's a full stack. It goes from the really high level all the way to the machine code, as opposed to the virtual machine and the interpretation. So that's pure compilation is the extreme end, and then pure interpretation is the other extreme end. There is actually some fusion and some compromise between them, which is probably the most modern way of implementing languages, and it's called JIT, or just in time, and it's actually a very smart thing to do, because we want to make the best of the two worlds. Compilation, it's time consuming, and for learning, it's just it takes more time to pick up the language and to learn the features. But on the other hand, interpretation is you can learn very fast, because you don't need to create so many steps in order to get the feedback from the language. So you get your results right away through the scripting, right? But the advantage of compilation, once you compile it, although it takes time to compile the entire program, it is very fast. Execution is extremely fast compared to by the order of 100, sometimes 100 times faster than the interpretation. Interpretation is slow, as we all know, and execution. But for the sake of portability, like Java, you can write once and run everywhere. That's part of their slogan. This kind of decision you have to make based on these trade-offs. And this is just a view of what is the difference between the different methods in implementing languages. You have pure interpretation, hybrid, and JIT, and the pure compiler. Our model, in simple, is actually this: the pure compiler. It is simpler than the JIT, and it's faster than the interpreter. So I guess we find a compromise between these 4 methods, and it's good because you expose all the layers of abstraction from the high-level language all the way to the machine code, and that's a great difference and advantage to us. These are some examples where we talked about abstraction levels of a statement. In natural language, we could say, I would like to add 2 variables and store their sum. This is any, you can say that in a natural language. In algorithm, you could say, in pseudocodal algorithm, you could say, something like that, right? This is the next abstraction level, which is more concrete. And then the high-level language, like in Java, for example, we could say C equals A plus B. By the way, they're all the same meaning, right? But we are, going through the abstraction levels. Simply, this will be translated into this kind of instructions, which is actually one-to-many mapping. And then at the machine level, it's just merely a translation of humanly readable code into basically a machine readable code. But they are equivalent. Typically, we stop here at when we actually learning languages, we stop here at least at the computer science side. But in engineering, they will go deeper to microcode, and then they will definitely study the design of, let's say, ALU, the logic design, even beyond that, the transistors that makes the logic gates and the signals. We kind of have this in computer science, but not to the level of really fabrication and making and designing these hardware. We use simulations, of course, in order to understand how the logic of the hardware works and so on. We have that, but that is probably the lowest level when we get to the signals, right? Studying signals and how actually data is being transmitted at the analog level, not even at the digital level. So some required skills that we need in order to really get involved in such a big project. There's something in the discipline called Back-Snore form, which I'm sure most of my colleagues know. It's the formal meta language that you use in order to specify the grammar of a new language, right? Java CC is our front end that allows us to develop the lexical analyzer. We spoke about that, inshallah, later on. We need to know theory of compilers. We need a tool to implement our language, and we use basically Java. You could use any other language to implement, and we chose Java because of the familiarity, really. We need assembly language, of course, in order, because this is compiled language. You need to go get into the lowest level of translation, ultimately to the machine code. We need an assembler, which we use the MASM, but there's other versions. but we use that Microsoft assembler. You need basically scripting, because you need to manage all these components that they need to be coordinated and synchronized and controlled by shell scripting. Simple editor we used, you know, in our labs, we have a fancy integrated development environments that users can use and we use as instructors. It's, you know, it's really very convenient. But if you have your own language and you don't want to wait another year probably to create that fancy IDE, just use an available one. And I used basically Notepad++, which is pretty familiar to probably everyone. The organization, I'm sorry if I'm going fast because I have a lot of slides that I like to go over and show you some of the efforts that we have accomplished. This is the main process of simple, which is, you know, similar to other languages, starting from the, you know, the grammar, definition of the grammar, the syntax of the language, and with the use of the Java CC, which is a compiler to generate the lexical analyzer, and going through the translations and the syntactical analysis and the semantics and the generating the machine code and linking with other libraries and until, you know, basically you know, you are allowing a program to run. Okay. Now, since we have this really complicated environment, we need to keep things organized and traceable. For that, you know, I teach software engineering as well, and I should be following the same principles I'm teaching my students. So definitely, I designed a really well thought of process that will allow me, if I want to change something in my language, if you don't have a process, trust me, even if you are the developer of the language, you'll be lost because there's too much stuff that you have to keep track of. The versions, where is everything is located and how everything is connected. So I keep this process and I follow it from start to finish. Every time I want to introduce some feature, every time I have a bug in the language to fix, I have to follow systematically this process. And we teach that in classrooms, and you know, I follow it religiously in my projects. This is a kind of the context diagram where we are looking at the neighborhood really of the language. Simple here sitting in the middle, right? And the other systems are connected to it, which include you know, the scripting files, the class libraries from Java, the editor we use, the Java CC, our front end. These are libraries for input-output functions that we didn't actually develop, but we used already libraries, which is always the case. This is the modern way of developing software by adopting and configuring. You cannot really depend on yourself to develop everything from scratch, right? And you have the command prompt window for executing your programs. I would like to make a note on the scientific method and engineering method as it relates to really huge projects. And they are established hundreds of years ago. And especially relating to engineering method, it's really necessary to relate to it and to follow it as much as we can. Also, we can make a reference to other established methods in respected organizations like NASA. They have a design process that they follow. You know, and it's just inspiring, and we relate to it in our projects and our classes as well. This is I like to skip that. Also, I'm gonna skip some of that for the sake of time. I'm watching the time here, Fatima, don't worry. We're gonna keep it on time, inshallah. You know, this is all about software engineering, right? And I like to promote that every time I talk about any software development in my classes, in my talks. Is really very essential and critical that with the modern days that we follow a systematic and established process models and especially agile, where it's the modern way to develop software. And occasionally we like to make, you know, software a little more delicious, right? So of looking at the software stack as being really sliced vertically and horizontally, and you can see that this is a very helpful view when you understand the software being layered, and you don't have basically to address all the features at once, but you can take a slice of it and then implement everything in it in all the levels or all the layers of abstraction, and then you integrate more features as you go, right? So this is a view of how do you slice basically, you know, software layers from the top level until the lowest level. Some background about Java CC. I really I'm impressed with this tool. So if other colleagues are interested in using this, I would really advise and recommend them to, if they are interested in this type of work, right? Creating small languages or whatever, or compilers and so on. Java CC is amazing, you know, piece of software that will make your life easier. But it lacks, of course, at the end of the day, it doesn't do everything for you, of course. You know, it's very helpful in the front end, but you have a lot to work from that point. But it's a great help, absolutely. If you had to do it yourself, it's going to be a lot of headache in the front end. So we come to the grammar. That's the first thing you want to establish. You know, we all know, even in natural language, if you talk about a language, what is a language? You know, we start from basically the symbols. It is the alphabet need to be there. The alphabet need to be defined, which is a set of finite symbols. And then from that, you create the rules or the grammar or the syntax, we call it, for the programming language. So the grammar is the first thing you want to establish. Beyond the grammar, there's something called semantics. You know, the syntax is concerned with the form of the or the structure of the elements of the language. How do you, let's say, write a letter? How do you write a word? How do you write a statement or a sentence? And then what is the legal, right, form and syntax of these sentences and phrases or words even? That's the legal rules are called the grammar. But after that, grammar is not enough. You need to establish something called semantics, which is actually shed the light on the meanings of these statements that you established. So we had to do that. Java CC allows us to write the grammar and the legal tokens, which is the keywords that you want to reserve in your language. And we can go through them, but it's going to take a lot of time. So I'm just flashing some slides here to show you the concepts of the grammar. High-level structure after establishing all the legal tokens, which are the accepted or legal keywords. We want to design how does a program looks like, right? And for example, here we're defining global variables. We are allowing a main function to exist. We are allowing macros, allowing functions to be defined below that. So here you state the structure, the general structure of your typical program in simple. And then we have something called productions. Productions, a number. How do you generate a number in your language? How do you allow, let's say, a word, a legal name in your language? How do you write a function? How do you call a function, right? And all the features and the elements we are used to in any programming language, the if statement, the if else, the reading and writing, IO, right, facilities, and expressions, right, whatever it's arithmetic, logical, shift operations, bit operations, all of that need to be addressed in the grammar, right? So once you establish the grammar, now there is a long way until you basically allow a source code to be compiled. Preprocessor is one of the components that all languages use in order to pre-process the source code. For example, you have the importing libraries. You have to process before actually you establish or you generate the final code. Let's say your comments. We won't process comments. You just don't, ignore them. So that's a pre-processing, right? And other things that you want to take care of before you get into the real code. And then, Java CC, as we said, provides some services for us. We have an x86 main, which is the main class, the main engine for the compiler. We have another program for a tree. We look at the program, any program, and if you are familiar with the languages, and any program can be understood or viewed as a tree structure, right? So we have to model that. And then in the tree, there is a node, right? So there's a class for the node, should handle every node in the tree. We have a library that we use for basic IO and basic input-output operations. We like to recognize Dr. Irvin, who's in the located in Florida, and he's actually the author of a book I teach, and I communicate with him a few times, and then we talked about things related to the class, but I used his established libraries. It saved me time in order to design my language. Here, formatting is important because when you allow a user to write a source code, you want to make sure the indentation are correct, is nicely readable and formatted, and so on. We can skip some of this stuff. So coming to the actual program in simple, right? This is what we see in Java. This program actually an empty, useless program, right? It's an empty, it does nothing, but it is required in order not to get any errors, right? Your first trial in programming Java. But in simple, this is the smallest program possible. Just writing main and bracket, close bracket, right? Now, how do you say hello in simple, right? This is the code to say hello. Of course, these are comments and whatever, but this is how you say hello. Compared to Java, right? You have to write a lot, considerable amount of code in order just to say hello word. And in simple, we simplified that. We just say you need main and you need a statement, a message to be displayed on the screen with just a simple operator. This operator is called the output operator that I created, and it's just without the need of all that. You don't need to say system out, that print line, whatever. Just say whatever you want to say right after this operator. Variables, of course, since I worked by myself throughout the project. I am the only designer and developer and tester for the whole thing. Maybe that's a disadvantage, and that's why I limited my variables to only integers. I have strings that you can work with and display, but the only variable is an int. which is a 32-bit as far as assembly and machine code concerned. Of course, that can be improved, but I wanted to have it as simple as possible for learners to learn, what variables we use just integers. Other variables we can be extended. You have to deal with the floating point, which is another really branch of the project, which could be the same effort that I had already worked on. IO is very simple. If you use the this operator in one direction, it's an output. If you flip it to other direction, it's an input. Using the same operator to input and output, I think it's a nice simplicity and simple. Also, we use the tags because users want to be able to format their output, a new line, a tab. I wanna say more digits in my numbers, less digits. We allowed all that. I want it unsigned, signed. I want to display in base 10 or base 16, base 2, binary, whatever. All that is available in simple, and really in a simple way to do it. Arithmetic and logical and bit relational, all of these are available. I want to make some comments. I don't want to go through all that, but in probably all languages, you don't see this. And if you know languages, you will be basically probably surprised. This is a factorial, right? I made it as one of the operators. Factorial, you don't see it in, you see addition, multiplication, subtraction, division, modulus, but you never see a factorial. So I add it for convenience also, so users can, or programmers can say X exclamation mark, and that's a factorial. And also I made the power, right? This is actually the exponent. You don't see that in probably most languages, like Java, C++, and C, all these. Some languages, they have it, but I made it available to be able to say exponentiate, right? Or make a power instead of making a function. The if statement, nothing special, nothing really different here, is the same if statement. The if else also is available. The ternary operator is available. If you remember from other languages, you would be able to compact your if else statement in a single line. That is available also. A break statement is a standard in any language. It's available and simple. Exit, we made it really for debugging. That's a nice addition, that in your message you can say let's say hash code X, and just like N for new line and X for exit, so it can help you in debugging. And this really was a nice addition to the language. Coming to the switch, and this is, I like to make really a good note about it. What is our contribution here? In all languages that we know, I know several languages, and I didn't like the way they have it, because it's just a switch supposed to be elegant, and that's why we moved from if else structure into switch. It's supposed to be elegant, but it's okay, but it's not perfect in most languages. What I did here is make it further. I simplified it further. I removed the case and I removed the break, right? There's no more break and case statements in the switch. As you can see, it is super simple. You just put the case, whatever the number is, whatever the character is, and do whatever you want, and semicolon at the end. And the new case here, you need to write any special keywords at the beginning or at the end, right? So they're just the number of the case, and instead of default, we use the question mark, and that's the default option for us. So that was a new structure that actually doesn't exist probably in any language, right? We know that if else is ugly, and we know the switch is elegant. And I made basically a marriage between them to make the best of the two words. If a statement is powerful, that makes the possible of ranges. You could make a range like that, right? If grade greater than or equal to 97, you cannot make this in a switch statement. A switch statement needs to be a very specific value. It doesn't allow for ranges, right? So what I did is fused the two together, and I called it SWIF, from switch and if. And now it allows, this is SWIF structure, it allows for the elegant form that we are used to from switch, and it allows for ranges in your basically cases. Another new thing that I added to the language, it's kind of a shame, right, that we keep talking about, especially who teaches programming, right? We keep talking about looping, right? The loops. We teach the students loops, but we never use the keyword loop. Actually, we use the for, the do, and the while. What I did in my language is make every loop, every type of loop can be done using the loop instruction, right? So we have only one loop instruction that handles the for, the do, and the while. And here's how you do it, right? You don't see this often in languages. Loop for a specific number, that's available in simple. Loop a variable, that's available. This is typical for loop. It's available under loop, the same keyword. And this is a for. And this is a while, but under the same loop. And this is a do loop, right? At the condition at the end. So that simplifies. And these are some examples, of course, so on. Okay. 10 minutes, Fatima, I guess, is it?
Let's say maximum 10 minutes. If you can,
10 minutes. Right.
Let's say 5 minutes should be, because we need to open also floor for the questions, and we all have classes in the afternoon. Okay. So if we can keep it at 5 minutes, it would be awesome. Inshallah,
thank you. Macros and functions, that's another addition that I did in simple, that whenever you go to a language, macro and function are different concepts and different constructs. What I did in simple, and make them the same. There is no need, right? So the user at the user level, they don't need to know how we are handling behind the scenes. So I simplify that, and then you exactly can write and call macros and function exactly the same. What else we have? There's actually some examples of functions. How do you actually create a function? How do you call a function? Other features, one-dimensional arrays, right, exist and supported in simple. Two-dimensional arrays supported. Searching as an application, sorting as an application, just to demonstrate, the capabilities of the language. File I/O is available. Reading and writing, saving, processing files are there. Stack for data structures, queues. I demonstrated how you actually use stacks and queues with other, search and sort algorithms that we did. The use keyword, I wanted also the programmers to be able to reuse, just like import statement in Java, right? If you have other files that you have already written, you don't have to reinvent the wheel. You just use them, and like importing them or using them in your new program. So that simplifies your source code as well. More examples. Highlights of simple. That I hope that by this language, we simplified the learning environment and the way beginners actually learn, by having them not to worry about libraries at the top, like there's no 10 lines I need to import in order to start my program. Standard I/O is very simple, no variables, only no even a single variable, so just stick with the integers for now. Loops are simplified, minimizing the keywords. The SWIF is a new structure that actually is powerful and elegant at the same time. New operators, the power, the factorial, the XOR that doesn't exist probably in any language. Macros and functions are the same. They use keyword and so on. Finally, I want to speak about some lessons learned in like 1 minute, Fatima, if you allow. Simple was not simple undertaken. I hope I simplified the environment for learners, but it wasn't simple, for me. But that's understand. But it's enjoyable, absolutely enjoyable. Some regrets, if I go back, probably that's always the case when you look back and then, I could have done that better and so on. Software engineering is imperative in such projects. It was an amazing, rewarding journey and experience. Can be addictive once you have the flow going. You wanna basically design a new huge language, but that's what happened to me. Sticking to fundamentals, even if it means slow progress. I learned that lesson. Few test subjects were involved, basically my own kids, right? And myself. Simple accessibility, we need to work on that, probably in student projects. Integrate into courses, I'm thinking about that. Patenting, I need help from AUK to look into that. We'll see that, inshallah. And today is a great opportunity for anybody's listening. Please, we need your support. What is the next for simple? Hopefully the best. These are some accomplishments that we so far I have accomplished with simple. I've been invited to IEEE conferences, 3 of them. I have published 1 IEEE conference paper. I have published 1 journal paper, and I have published a book in the all under simple. Thank you so much for being patient and listening to me going through this. Hopefully not too boring to you. I appreciate your support. Thank you so much. And we are open for any questions.
Thank you so much, Dr. Aaron. So as Dr. Aaron said, we are open, basically we're going to open the floor for questions. If you have any questions, you can use the raise hand option so that we can check your questions. And before that, maybe meanwhile, if we can at least take a picture. So if you're ready, please, if you can turn on your cameras so that we can get a group picture so that I don't forget. At least it's done. Dr. Aaron, would you like to keep your slides, or do you want it without? I'm fine with both. So if you want to just the group picture without the slides at the back, okay,
yeah, I
so
stopped sharing. So
okay, so I'll do it from my side.
Yeah.
So once, yeah, it's gonna be easier. So I'll ask again if you can please turn on your cameras for the photo, so we can take a group photo, please. Okay, once everyone is ready. Okay, so I'll try to take one right now. Let me check if it's working. Let's see. Okay, maybe one more just in case, because sometimes it doesn't work. So I'll take another one also. Okay, so, okay, one more. Okay, people are still joining, so or turning on their cameras. So, okay, let's take one more then. Yeah, I think that's good. Okay, so we're good with the group photo. We're ready now for questions. So if you have any question, any comment, any suggestion, anything that you would like to share with us. So mainly engineering, I would say, engineering colleagues, it's gonna be easier.
I'm so sorry, yes.
So if I could ask a question, Dr. Aaron, thank you very much for your presentation as well. the nerd in me loved it. So you had someone here who enjoyed it quite a bit.
Thank you. Good to hear that. Very good.
I just want to ask, for educational purposes, how is simple advantageous to like Python or some of the more simplistic programming languages?
Very good. Early on, I kind of talked about this issue where, you know, Python is basically interpreted and scripted language. And you don't get to see the whole depth of the abstraction levels from the high level all the way to the machine code. I chose that path, which is a pure compilation, because it's the deepest actually. And I wanted to go across these levels just for the learning, basically objectives that I have. Interpretation is limited. Pure compilation is the traditional way of translating source code into machine code, which has definitely carries much more weight and much more opportunities for us to learn. So that was the main idea behind me selecting, you know, compilation versus higher level or interpreted or scripting languages.
Do we have any other question? It's true, it's a little bit technical, so unless we are familiar with programming, it's really hard to. I'm familiar with certain things, but yeah, not.
I was hoping from my close colleagues, you know, but it looks like they do want to give me a hard time.
Exactly.
So,
excuse me, Dr.
Yes.
Aaron. I have one quick question, Dr. Aaron.
Please.
Yeah, no, thank you. Thank you, first of all, for the nice presentation. And it's an interesting topic to all engineering, I believe.
Thank you.
Since this is for educational purposes, I think you haven't mentioned the age of students you are targeting. Is it for high school or university? Because as you know, for university students, they have to be exposed to real languages, Java and C++, Python, whatever. Because if we teach them this simple one, they might think that programming is so easy. And then when they get to the real, or let's say the other programming languages, they might get, shocked. They say, this is not the language that we have learned in, let's say, year one or so. So if you can just clarify or like...
That's
So
thank you, Dr. Khalid. Thank you very much. That is a great question and difficult at the same time. So I know somebody, will ask this question, but I was hoping not. But it's a difficult question. But what can I say about this? If simple today, right? The way I have it today. Was presented to the computing community back in 1958, you will be teaching, Dr. Khalid, you'll be teaching simple in your classes.
And right? I might adapt it even now if it becomes, publicly available.
I understand your point of view, and I really respect it. And I'm aware of it. That means if I take a symbol to the class and make it official, right? Yes, it will not be competitive to these well-established and respected, and actually in the industry, right? Language, like you mentioned, right? But the difference is that is one objective to learn, to give beginners an opportunity to learn programming in a simple way, right? But it's not the only objective. If you remember, I talked about compilers, I talked about concepts of languages, I talked about assembly, right? These are all exposed, is an open source, and we can look at the design of the language and can learn from the implementation of this language, how things work under the hood. That was a major objective. but learning that coding is actually a side, I would say a byproduct, that I simplify the language. Whoever wants to know how actually programming works, not necessarily to get a certificate and go actually have a job because I know simple. No, nobody would hire you, even me. Right? If you know how to program with simple. But yes, there's other amazing, great opportunities for students to learn from simple.
Thank you so much, Doctor.
Thank you, Dr.
Thank you. Thank you, Dr. Khalid. I think Dr. Ali Mansour has a question. Go ahead, Dr. Ali.
It's not a question. Yeah, it is a question. In business, we have the capstone course is about simulators. Your programming language, I will take the simplified language, has looping and has switch if statements. This is an essential tool in order to test the assumptions that the teams are doing for simulators. Do you think we can further simplify it for the business students so that they can use it? Mainly it is the looping and if statements that I'm very interested in. And this would, because when I used to coach teams on simulators, this is mainly what we used to do. In essence, you have it in AI. You use that in AI. Can we use it also in the business field?
Thank you, Dr. Ali, for the question. This is my first attempt, and it was really a serious attempt in order to simplify anything that I think is complicated to students. And I presented, if you basically remember, I presented quite a few elements that I attempted to simplify at this stage. So, but for future, who knows? I keep my list of things to do. If you open my project now, there is a list of things to do, and some bugs need to be fixed. Other features need to be. It's by no means is complete, right? Otherwise, I'll be promoting this language as an alternative to Python tomorrow, right? But by no means is actually is complete. But well, I'll give you a deal, Dr. Ali. I'll give you simple, and then you can simplify it further. Work with me, Dr. Ali. Right?
By all means.
Thank you.
Thank you, Dr. Ali. Do we have any other question, any other comment, anything that you would like to share with us?
In the chat, anybody's asking or something like that?
Dr. Sharifa asked something, but then she said that you answered her question during your presentation.
Believe it or not, I read her mind, and right away I answered. See?
I think maybe we're good to go. So I would like to thank everyone for joining us today. As I previously mentioned, this was our last Faculty Speaker Series event for this academic year. So I wish you all the best, and we hope to see you again next year in our events. Have a pleasant day, everyone.